Hello, the topic is linked list. We'll write a program in C to create a linked list. So here is how linked list looks. Linked list consists of nodes. We always have a pointer pointing to the first node of the linked list. So this is a typical node of the linked list. It has two parts. The first part in which we store all our data, so that is called as data part. So for simplicity, our data part will be storing only integer, so data part. The other part of the node contains a pointer or will store address of the next node of the linked list in that node. So in fact, here is a pointer which is pointing to the next node in the linked list. So next node is having 20 in data parts, and the next pointer is pointing to the third node, so 30 here and 40 here. Let's say this is a typical linked list. So how to create this linked list in C? So to create this linked list, I will first create the first node of the linked list. Right? The logic is like this. First, create the first node of the linked list, point it by the first pointer. In fact, this node can be created by demanding memory dynamically. We'll see how to demand memory dynamically. Right? So we'll create the first node of the linked list. We'll ask the user for the data and we'll store that data here in this linked list. As we don't have any node to point to, so the next pointer of this first node will be null for now. Right? Then I'll create the second node of the linked list. Right? Before creating second node of the linked list, I will have a pointer. Let's say I'll name it as old pointer. I'll point that pointer to first, right? And that pointer I'll be using to create the link between nodes. That pointer will traverse and it will help us to create the link between the nodes. So now this old is pointing to first. After this, I'll create the next node, and to do that I'll use one more pointer called as new record pointer or new node pointer. I will use a new node pointer, and a new node pointer will point to the newly created node, and there then I'll read the data. As there is no node to point to, so this next will also be null here. Now once I have these two nodes, I'll be just saying the next pointer of this old will point to the location where this new node will be pointing to. Right? So I will create this link, and then I'll move this old pointer to this new node location. Right? And then I'll use again new node to create new node. Right? So new node will not point to this node now, but new node will point to the newly created node. Right? So new node is pointing here. Once I have new node and this is the old node, I'll simply say the next pointer, name of this pointer by the way is next. So the next pointer of the node pointed by old will point to the new node location. Like this. Like this, I'll create one more node if I have 4 nodes in the linked list. And that node will be pointed by new node again. So before that, I have moved old here. So now again I'll say old arrow next is equal to new node. So this link will be created. So let's write the program to do this. So here is our structure which will be using to create this node. The structure used is like this: struct node. The structure has two parts. The data part is containing a simple integer variable, a value int data. Right? The other variable in this node is this pointer, right? This pointer is pointing to the node again. So the type of this node is structure node. So we'll need a pointer which is of this type, struct node. The name of the pointer is next, right? So this is a pointer. So this is the structure which we'll be using to create this linked list, right? Now let's write the main function and we will create the linked list in main only. So here is our main function, void main. So as we saw here, we are going to need 3 pointers of structure node type. So let's declare them. Struct node. First pointer will always point to the first node, will not move this. First old pointer, which will help us to create the link between nodes, and new node pointer will help us to demand memory for new node. Also we'll be needing some integer variables, total number of nodes, then I, and we'll declare if we require more. So now I'll ask the user printf how many nodes you want to have in linked list. That question I'll ask to user. User will say he would like to have n nodes. So I'll read those n nodes in variable n, which we have declared. Then we'll simply create the first node of the linked list. So now to create first node, I have to demand memory dynamically, right? So to demand memory dynamically, I'll use the library function malloc. So I'll ask malloc to allocate me memory of the size of this structure, right? So I'll use the size of keyword to calculate the size of this struct node, size of struct node, right? So this struct node is in the bracket of the size of. So size of will calculate the size of the structure node, and that much memory will be allocated by this malloc for us. Now malloc reserves that much memory and it returns you the address of memory reserved for you, right? Now you have to point a pointer there, or you have to store address of the memory written by malloc to you. But what kind of pointer you can point there? So the idea is malloc returns a void pointer. That means you can point any pointer to the memory which is reserved by malloc. That means the type of memory is void, or void pointer is written by malloc, but we want to point there a structure node type pointer because we want to treat that memory as a structured node memory. So we'll convert, or we'll typecast that memory into structured node type memory. So struct node star. So malloc return a void pointer, we convert that pointer into struct node type pointer. Now we'll point a pointer there, first pointer, right? So first is equal to struct node star malloc size of struct node, right? So if I rewrite this statement, let me rewrite that statement just to be little clear. So it is like this: first is equal to struct node star malloc size of struct node. Okay, so at this what will happen is, let me show it here. With this we'll get this memory. Malloc will reserve this memory, let's say on maybe 1000 memory location, right? And then that memory is address, this 1000 will be returned to you. Will typecast that memory using structure node star typecasting, and we will assign that address to first. So now our first is pointing to that memory. Right? Now as of now we don't have next node, so we'll say the next pointer here will be null, because now this is structure node memory. I have two fields here, data and next pointer. Right? So I'll say the next pointer of the location being pointed by first is equal to null. So I'll say first arrow next is equal to null. So this pointer will be set to null now, right? Then I'll ask the user to enter data for first node. I'll say printf enter data for first node. So user will enter that data scanf, and the data is integer quantity, so I'll use %d, and the data has to go here now, and this field's name is data, but that data is inside the node pointed by first pointer, so I need to provide address of this location, right? So this is the field named as data, which is inside the structure being pointed by first pointer. So in fact name of this field now is first arrow data. I'll provide address of this first arrow data by using ampersand operator, ampersand first arrow data. So the value entered by user will go directly here. Let's say user enter 10, it will 10 will be stored here. Now as I said, we'll take one more pointer old, which we already declared here, and we'll point that pointer to the location where first is pointing. That means we'll give or assign the value of first to old. Right? Old is given the first's value, that means old is pointing here. Then we'll create the next node or new node by using a new node pointer. So we'll write the same statement, that means we'll demand the memory and point a new node pointer there. We'll write the same statement here. So new node is equal to, so let me write it on the next page. So let me write on the next page. So what I'm doing is now I'm demanding memory for new node. So new node is equal to same statement. I'll write struct node star malloc size of struct node. Right. So malloc will reserve memory and it will return that memory address to us, and will store that address in new node pointer, which we have already declared here. In fact, the situation will be like this. So because of new node, we'll get memory, and that memory will point by new node pointer. Okay. So now again we have to set the next of this new node to null, right, and read the data here. So we'll say new node arrow next is equal to null. Arrow operator we use to access the fields of the structure pointed by a pointer, right? So with this, the next field of this new node will be set to null, and now we'll ask the user to enter the data at this new node. So we'll say printf enter the data for next node. So user is going to enter the data, and that data has to go in the data field of new node. So we'll now do scanf and %d, and the location is new node data. Okay. Then so far what we have done is we have user has entered data for this node, and that data has gone here, right? So far we have done this, right? Now what we want to do is we want to set this new node arrow next, sorry, old arrow next, we want to point it here, right? So the next step will be the next pointer of the old node will point to new node, and then we'll move this old to this location, that is new node location, right? So these two things we would like to do. So we'd say old arrow next, the next pointer of the node which is being pointed by old will now point to the new node, and this will create the link between the old node and the new node. Then we'll move this old pointer to the next location, and the next location is new node. Now with these two statements we have this. Then again we'll demand the memory for the new node or the next node, and that memory will be pointed by the same new node pointer. We'll reuse it, right? And then we'll read the data there, set next pointer to null there, and then we'll say old arrow next is equal to new node and old is equal to new node. In fact, if you see, we'll repeat this code for n-1 time. Why n-1 time? Because we have created the first node here, and these remaining nodes will be created by using this code. That means I can put this code inside a loop like this for I assigns to 2, because I'm starting creating nodes from 2 onwards in this block. So 2 I less than equal to n and I plus plus. So repeat this code, right? Now this code will get repeated n-1 time or from 2 to n times, right? So creating nodes from 2 onwards, because first node is created out of this block by using this code. We have created first node. And at the end of this code we'll have the linked list created. Now to print this linked list, let's say we have this linked list created at the end of this code. We will definitely have this linked list created at the end of this code, and our old pointer will be somewhere at the last node, right? And now we would like to print that linked list because it is in memory. This linked list is in memory, and we would like to show it on the screen or output device. So we'll like to bring the old pointer to the first node. The first node is being pointed by the first pointer, and then I'll traverse the linked list till I reach to the last node. So to print the linked list, I'll reuse the old pointer, I'll bring it to first node, right? Then while old is not equal to null, right? I'll say printf %d old arrow data. After printing the data on the first node, we'll move old to the next node, and next node is being pointed by the next pointer, being pointed by the next pointer of the node being pointed by old, right? And then we'll remain in this loop till this old reaches at null, right? And then at the end of this we'll have the entire linked list printed. So we'll say get ch, and then we'll stop. So this is the simplest possible code to create the linked list. Let us just see one more time what we did. So the linked list, we said, looks like this, right? So to create this linked list, we need a structure, because this node is a structure type node. Two parts, data and next pointer, right? So data stores data, and next pointer point to the next node in the linked list, right? So now, after declaring this structure, we go to main, right? We need 3 pointers. As we said, the first pointer will always remain on the first node. Old pointer will use to create the links, and the new node pointer will use to create demand memories for new nodes. We will ask the user how many nodes you want to create. User will say n node I want to create. So we'll create the first node by using malloc, and we'll point first pointer on that first node, right? Then we'll create the subsequent nodes by using this for loop. Every time we demand memory for new node will be pointed by this new node pointer, right? And then we'll create the link between the old node and new node by using this statement, right? And we'll move this old pointer to the new node, and we'll remain in this loop till we have all the nodes created in the linked list. And this code we can use to print the linked list, right? Starting from first node till the last node, right? So that's how the linked list is created and printed. So thanks for watching.